Today we're talking about parallelograms. So first we're going to go through some rules about parallelograms, and we're going to mark some different facts on a parallelogram. So I'm going to go ahead and draw a parallelogram here. And our first fact is going to be that parallelograms are quadrilaterals. Okay? And if you remember from earlier in the year, then you know that a quadrilateral, the prefix quad, means that it's going to have 4 sides. Okay? And that's really important. So all parallelograms are going to be quadrilaterals. Our next fact, actually there's a hint for it in the name parallelogram, and it is that opposite sides are parallel. Okay? And remember that we can write parallel either in words or we can use the 2 lines that mean parallel. And when we're marking those on our shape, then we use triangles to do that. So the sides that have the same number of triangles are the sides that are parallel. So that would mean this left side over here and the right side over here, those are parallel because they each have 1 triangle. And then the top and the bottom are parallel because they each have 2 triangles. Okay, so that's our second fact. Our next fact is going to be that opposite sides are congruent. So we're still talking about sides here, and this time we're saying that they are congruent. Remember that we can mark that on our picture using the little tick marks. So remember that the sides with the same number of tick marks are congruent. So the left and the right, again, are congruent, and the top and the bottom are congruent. Our next fact is dealing with angles. And so this one's going to say our opposite angles are congruent. Now remember that opposite angles are not going to be next to each other. So for example, if I name this parallelogram A, B, C, D, then A and C are opposite angles across from each other, and B and D are opposite angles. They're across from each other. So those opposite angles have to be congruent. The next fact talks about consecutive angles. So first of all, let me remind you that consecutive means that they are next to each other. They follow after each other. And so consecutive angles are supplementary. And we also need to talk about or remind ourselves that supplementary means that they're going to add up to 180 degrees. So let's see, which angles are consecutive, right? So we would have angles A and B. These are next to each other. That would mean that A plus B would equal 180. B and C are consecutive. So that would mean that B plus C would equal 180. C and D are consecutive. So we add those, they would equal 180. And then D and A are also consecutive. So they would also add up to 180 degrees. Okay. Our next fact is actually a compilation of a new piece of information and then logic using what we've already talked about. So you can either remember it separately, or if you just remember the other rules, you should be able to arrive at this one pretty easily. And so our next rule is that if you have one right angle, okay, so let's say this angle A here is a right angle. Put that in a different color, sorry. Okay. Then that's going to mean that all of the angles have to be right angles. So if one angle is a right angle, then all 4 angles are right angles. Okay. And so the way that we could just know this is if we say angle A is a right angle, and that's all they gave us, we would know automatically that our opposite angle, angle C, has to be a right angle. So we already learned opposite angles have to be congruent. And then we know that angle A plus angle B has to add up to 180. And so if we know that angle A is 90 degrees, we could solve for angle B, and we would find out, when we do that, that angle B also ends up being 90 degrees. So it's a right angle. And then if angle B is a right angle, the angle opposite it, which is angle D, is also a right angle. Okay, so if one of the angles is a right angle, then because of all of the other rules that parallelograms have to follow, then all four angles are going to be right angles. Okay. We have two more facts. I'm actually going to draw us a fresh parallelogram here. And so let's go ahead and give this one a new name. We'll call it E, F, G, H. And on this parallelogram, we're talking about diagonals. So first of all, let's talk about what is a diagonal. And a diagonal is going to start at one vertex, and it's going to go to the opposite vertex. Notice that if we try to draw it to the vertex, or one of the vertices next to it, that would just be one of the sides of the parallelogram, and so that wouldn't really help us out any. That's not a diagonal. So in this case, our two diagonals, we are going to list them out, are going to be EG, that's a line segment, and FH. Okay, and we have two facts about the diagonals. So our first fact is going to be, our first fact about the diagonals is going to be that the diagonals each are going to cut the parallelogram into two congruent triangles. So diagonals cut the parallelogram, and the symbol for parallelogram just kind of looks like a slanted rectangle. Okay, looks like a parallelogram. Cut the parallelogram into two congruent triangles. Okay, so that means that this triangle EFG is congruent to this triangle GHE. Those two are congruent triangles. Our second diagonal rule is going to be using both diagonals at the same time. And it says that if you draw both diagonals, that those diagonals are going to bisect each other. So let's remember what bisect means. Okay. And so if you look even at our root words and our prefixes here, right, sect means we're going to be dividing up into sections, and bi means it's two sections. So we're dividing these into two congruent sections. So that would mean, if I call this intersection point here M, that from E to M and from N to G have to be congruent. And then similarly, from F to M and from N to H also have to be congruent. And some of you are thinking, well, that's all fine and dandy as long as it looks like this, where it looks like a rectangle. What about if it's one of those really slanted parallelograms? So let's go ahead and draw a really slanted parallelogram. Okay. So it looks something more like this. And adjust here. There we go. Okay. So even if you have something like this, keep in mind our diagonals are not going to be congruent. They are just going to bisect each other. So that means they cut each other in half. So these two parts of the blue line, those are both congruent to each other. And then the two parts of the red line, those are both congruent to each other. Now the red line and the blue line are not congruent. Okay, so each little piece is not congruent to all the other pieces. It's just that they cut their own line in half. Right? So that's going to be really important as we go through this. Okay, let's try some examples just to get you ready. And so what if we gave you a shape and we tell you it's a parallelogram, and I tell you on this shape that this angle is 5x and this angle is 100. And so what do you know about those two angles? Okay, we know that they have to be congruent, so we're going to set them equal to each other, right? And then you could solve for x. What if I had given you this angle down here, and I had told you that this angle was 3y minus 10? Okay. Well, we know that C and D have to be supplementary because they're consecutive angles. And so I could write out an equation that would say 3y minus 10 plus 100 has to equal 180 degrees. And I could solve for y. And in case you're interested, I went ahead and worked these out for you so you can check your answers here. Last example. If I were, it's really not a full example, it's just to give you a suggestion on how to work something out. If I were to give you the 4 vertices of a parallelogram, okay, and I wanted to know where do the diagonals of this parallelogram intersect? Okay. A couple of suggestions. Number 1 suggestion is going to be graph it, because it's going to make sure when you graph it that you find where the diagonals intersect, and that you don't accidentally use the wrong coordinates for, say, one of the sides. Step 2 is going to be use your midpoint formula. Okay? So remember that since these two diagonals are going to intersect right at their midpoints, right? That's what bisecting each other really means. And you can use the midpoint formula to find the midpoint of one or both diagonals. Okay? And then 3 would be to go graph your answer and make sure that your answer makes sense. Okay? For example, if you're trying to find the midpoint of BD or the midpoint of AC, and your answer, the number of the coordinate you get is way out here, not even inside your parallelogram, then you'll know that you're off. Right? That you made a mistake, and you want to go back and check that. And the most common mistakes on there are made with negative signs, right? So just double check your work here. So that is my last suggestion for today. Thank you very much, and I hope you have a lovely day.